Hello everyone. In this lecture, we will see third type of non-linear partial differential equation. Means an equation containing four parameters variables p, q, x, and y, as shown here. So for solving this type of equation, we have to separate terms of p and x on one side and terms of p, q, and y on other side. It means that the given equation will contain four variables p, q, x, and y. Okay. Now, for solving it, we have to separate terms of x and p on one side and terms of y and q on other side. After separating the terms, we have to consider this left hand side as well as right hand side equals to a, or sometimes we will consider it as a square, which is a constant. So let's consider it as a or a square. Now, from this equation, we have to find the values of derivatives p and q. Meaning of this equation is that either LHS means the terms containing x and p will be equal to a or a square, or RHS means the terms containing y and q will be equal to a or a square. From one side, we have to find the value of p. From other side, we have to find the value of q. And after getting values of p and q in terms of a, we have to find here values of p and q. After getting values of p and q in terms of a, we have to substitute their values in dz. It is equal to p dx plus q dy, and integrate this equation, which will give the required solution of given non-linear partial differential equation. Now we take a problem based on this type. Solve px tan y equal to q plus 1. Px tan y equals to q plus 1. So as usual, first we'll write given partial differential equation. That is p into x into tan y equals to q plus 1. P x tan y equals to q plus 1. Now we can see here that this equation contains four variables p, q, x, and y. Z it is not present here. It contains four variables p, q, x, and y. Therefore, it is of the type f of p, q, x, y equal to 0. And for solving this equation, we have to separate the variables. So separating x and p on one side, comma, y and q on other side. So we have to separate the terms. So on left hand side, we can see that we are having p, x, and tan y. So tan y is a function of y. Transfer it on right hand side. Above equation, it can be written as px that is equal to q plus 1 upon tan y, which gives p into x that is equal to q plus 1 as it is, and 1 upon tan y, it is nothing but cot y. So this is simplified format of the equation. So in this manner, we have separated the terms of x and p on one side and terms of y and q on other side. Now this equation, it is of the form, therefore it is of the form f1 of x comma p, it is equal to f2 of y comma q. So for solving this type of equation, therefore for solving this type of equation, we have to consider this left hand side f1 of xp and right hand side f2 of yq as equal to a, or somewhere we will take it as a square. It depends on degree of derivatives p and q. If degree of p or q is 2, then we can take it as a square also. Otherwise, just keep it as a. So we are considering left hand side and right hand side both are equal to a. So it gives LHS that is equal to a and RHS that is also equal to a. So LHS of this equation 1, LHS of this equation, that is p into x, that is equal to a, and RHS of this equation q plus 1 into cot q plus 1 into cot y, that is also equal to a. Now, from first equation, we have to find the value of parameter p, and from second equation, we have to find the value of q. These are nothing but derivatives. And solving a differential equation means that we want to eliminate derivative from that equation. So from LHS or from first equation, we have to find the value of p. From second equation, we have to find the value of q. So it gives p, it is equal to a upon x. So it is the value of p. And second equation, q plus 1 equal to q plus 1 into cot y equal to a. It means that q plus 1, that is equal to a upon cot y. And it means that q, that is equal to a upon cot y means a tan y, and plus 1 जो लेफ्ट हैंड साइड पे था राइट साइड पे ट्रांसफर करना है, इट विल बिकम -1. So it is the value of q. So we got the values of p and q. Finally, required solution can be obtained. It is given by dz, it is equal to p dx plus q dy. Substitute here values of p and q. जो values हमने find किए वो दोनों values को यहाँ पे substitute करना है, and after substituting the values we have to integrate it. So it will become dz, it is equal to p dx, value of p a upon x dx plus value of q. Value of q, it is a tan y minus 1 into dy. And now integrate this equation. After integrating, we will get the required solution. So therefore, on integrating, we get integration dz, it is equal to a, it is constant, into integration of 1 by x dx plus again a, it is constant, into integration of tan y with respect to y, and minus integration dy. We have applied integration separately on this bracket. Integration of first term minus integration of second term. So integration of dz, it is nothing but z, it is equal to a into integration of 1 by x, it is nothing but log x plus again a constant as it is, integration of tan y, it is nothing but log of sec y and integration minus dy, it is nothing but y. So that is the required solution of given partial differential equation, which is required solution.